All right, so now we're in class 2, exercise 2. Here you can see at the top here, class 2, exercise 2. And we're starting to talk about hashing algorithms. This is a fantastic topic, very fundamental that you understand hashing algorithms. And it says think of them like fingerprints. Think of it as a one-way, another way to think of it besides a fingerprint, like takes a unique fingerprint of a file or a document or a piece of string. Think of it as taking as a one-way function to where it creates a digest or a summary or a simple identifier of that text that's uniquely tied to that text that cannot be reversed. So once you create the fingerprint, you cannot go back from the fingerprint back to the file or the file contents. So they're called one-way. They're also one-way functions. All right, this one we don't have to do anything on our application, but we do have to try to create some hashes. So let's use this online hashing generator. So there's a lot of different of these functions for generating hashes. We're going to use MD5, which is a bit older, shorter one. So we're going to create secret. So notice as you type, more text comes up. So notice right now it's E69. If I come back, it's hashes to the exact same thing. So if you look here at the bottom, the hash stays the same. I usually look at the end of it or at the beginning of it to look at the least or the most significant bits. Technically, there's no least and most significant bits, but I can't compare everything. I just look at the end of the beginning. So secret 551, or if I take that away, it comes back to EE69. So I got back to the same hash. All right, we changed the input by one letter. Let's type a whole sentence. Secret is the name of the game, and it is not getting any longer. So no matter how long this text is, and in fact how long this file is, the hash will stay the same. Now obviously there's not an infinite number of these hashes, so there's always a limited number of hashes, and so determined by the size of the hash itself. And so obviously the longer the hash, the more uniquely you can identify content, and the harder it is to go from the hash back to the file itself. It's not impossible, but it's harder. It's considered a brute force approach, just like you would take a password and try to guess its hash. You would basically, it's in the same ballpark. All right, so now let's use that was MD5. Let's use SHA-256. SHA-256 is considered kind of a modern standard today. And it works really well. It's used for a lot of cryptographic functions, but let's say crypt. So what is the first thing that we notice here? The hash is just a wee bit longer. That one is about half the size of this one. Oh, secret, same thing here. If it ends up in 318D2, sorry, it ends up in A25B. And if we go back to secret, it's A25B. So no matter the text always gets the same hash. If you change the text, then obviously the hash changes, and as well the length of it doesn't change if you type more characters. So that's it. That's about hashes. Very, very important functions. There's also a SHA-3 apparently, and there's a bunch of other algorithms to be used. But this is the one. This is the primary ones that we care about, and the ones that are readily available. So let's stop there. That was exercise 2.